All right, lesson 2.7 is piecewise functions. Now, everything that we've covered up to this point when we've graphed a line is basically been covering all of the possible numbers that is. So for example, if we did go back to our x plus y equals 5, remember our answer could be 4, 1, could be 1, 4, could be 0, 5. We could even do negative 97 and positive, let's make this positive 97 and negative 92. So we get our positive 5. So in other words, the order doesn't matter. In piecewise functions, the good news is it goes back to quick graphs. If you remember, slope, y-intercept will make things a little easier. But the only difference is instead of wanting the entire graph, now we're only going to want a piece of the graph. So for example, on this graph, we only want from where x is 2 to at most where x is negative 3. Okay? That's as far as we want to go. And then the graph flattens out from where x is 1 to x equals 5. Okay? So let's take a look at one of these. Now, I will tell you that the problem looks a little uglier than it typically than it actually is. Okay? All you're really doing here is you have two graphs. Okay? And if you remember, f of x is just another way of writing y. Stands for the function of x. Okay? So, in other words, this is going to be y equals x minus 4. Okay? Now, we've graphed those. That's what we did back in lesson 3. It's simply in slope-intercept form. So if you remember, your slope is 1. In this case, it's 1 over 1 because we need the rise. Your y-intercept is negative 4. Okay? The only difference in piecewise is this second piece. Okay? Two things. The second piece is the first difference. Okay? And all this says is, so if I graph this just like I normally did. Now, if you remember back in lesson 2.3, we were writing items that had, or we only made 2 points. Now we're going to need to make more than 2 points. We need to initially put our y-intercept 1, 2, 3, 4 on the y-axis at negative 4. And then we'll do our rise. Rise 1, run 1. 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 Okay, and that's really enough. Okay, I mean, if we need more, we can always put more dots in. Now, we also need to make sure that we pick some points on the other side. Okay, so we've got to keep the same rate of change, and so remember that a positive can also give me, I can go down and to the right, down and to the right, down and, to the left, down and to the left. Going the right direction, said the wrong thing. Okay, so that's going to give me my straight line. So here's where the difference comes in. The difference comes in is I only want points where x is greater than or less than or equal to 1. Easy way to remember this is, which way is it pointing? It's pointing to the left. So I want where x is 1, so remember I go on our x-axis, and where x is 1 is that point right there. So I want all of the points where x is less than 1. Well, yeah, x is less than 1 here, that's 0. X is less than 1 because that's negative 1. Negative 2, negative 3, and negative 4. So basically, this is telling me I want only these points. Okay? And since it's an or equal to, I need this to be a filled-in dot. Okay? So basically, I don't want these dots. So we're just going to erase them and get rid of them. Okay? So the second piece of this, that's 1, because that graph is only good where x is less than 1, which is the part that we graphed. So the second part is, this has the second function, y equals 3x. Okay? Just like we graphed it before, we need a slope, and remember it's always the number in front of the x. So in this case it's 3 over 1 because we need that rise over the run. Whole numbers go over 1. And since there's not a number here that we're adding, that indicates that it is a 0. Okay? So if y is 0, we got to rise 3. 1, 2, 3, run 1. 1, 2, 3, run 1. 1, 2, 3, run 1. Okay, and we will at least want to get 1 point on the other way. We're going to go down 3, 1, 2, 3, and down 1. Okay, so that's what that graph would look like. But again, that other component of this is we only want the numbers where x is greater than, or it's pointing to the right. So that tells me I want the numbers that are on the right. So here x is 1, x is 2, 3, and we could keep going. So we want all of these components. Now you do need to be careful, because if x is 1, we're going to go with this graph. X doesn't satisfy, if x is 1, it doesn't satisfy this one. But I do need to indicate, because if x is 1.1, that will work. So this dot right here needs to be an open dot. Okay. So and we can get rid of these dots. So basically all that indicates is that this is our function to 1, and then once we hit 1.1, we jump up here. Okay. All right, so let's go ahead and take a look at another one of these, because I know these could get kind of confusing, but if we keep stuff straight, it's not too bad. Okay. All right, so remember, we just have two functions. F of x just means y. So the first one is y equals x plus 4. The second one is y equals 2x plus 4. Okay. So remember, our slope here is 1 over 1, and our y-intercept is 4. All right, so let's go ahead and graph that one. So our y-intercept is 4. 1, 2, 3, 4. Rise 1, run 1, rise 1, run 1, rise 1, run 1. Okay, and then to get the same slope, because it is a positive slope, we're going up, we got to go down and to the right, down and to the left. I get my down and to the left. Okay, but then you just have to decide where. Okay, first of all, my 0 is my boundary line. So here's where x is 0. This line right here, it's the y-axis. Okay, so that's my point. So, and since it's pointing to the left, it also indicates I want the numbers that are less than 0. So -1, -2, so all of these numbers. And it's the or equal to at the bottom, so I keep the dot filled in. So we can go ahead and get rid of those. Okay. All right, so y equals 2x plus 4. So in this case, remember, the exact same thing. Slope is 2 over 1. Y-intercept is 4 again. So we're going to go up to 4. 1, 2, 3, 4. Now it's already filled in, so typically, because this is not the or equal to, I'd leave an open dot. But I'm going to rise 2, run 1, rise 2, and run 1. Okay. And if I want to go the other way, down 2 and run 1. But I need all the numbers that are greater than, so we're going to go with these. And that's what your graph would look like. Okay. Okay. All right, so let's do one more together, and then I'm going to have you try one and see where we go. All right, so this one, f of x equals 1/2 x minus 4 if x is less than or equal to -2. And then y equals 3 minus 2x if x is greater than -2. So remember, we have two functions. Y equals 1/2 x minus 4. And the other one is y equals 3 minus 2x. So here, remember, your slope is 1/2, and my y-intercept is -4. So on the y-axis, 1, 2, 3, 4. I'm going to rise 1, run 2, rise 1, run 2. And then just to make sure, in case I need some on the other side, I'm going to go down 1, and then I got to go to the left 2 to keep that same rate of change. Down 1, over 2. All right. So, but I want numbers that are less than or equal to -2. So if you'll notice, it's pointing to the left. So I got to first of all go where x is -2. So x is -1, -2. So that's my starting point. So I just have to decide, do I want numbers on the left or do I want numbers on the right? Since it's less than, I want numbers on the left. So I want these numbers, open or close dot, and it is closed. So I can eliminate those. Okay. And then we just do the exact same thing for the next graph. So remember, your slope is coefficient of x, which is -2 over 1, and my y-intercept is 3. And you need to be very careful about those, because remember, your slope is always whatever is in front of x. Your y-intercept is the constant that doesn't have any variables attached to it. So let's go ahead and plot those points. So my y-intercept is 3, 1, 2, 3. And my slope is -2 over 1. So I'm going to fall 2 and go to the right. Fall 2, go to the right. Okay. So let's make sure we get them the other way. And remember, I can flip the negative. So in other words, the top can be positive, the bottom can be negative, because the Positive divided by negative still gives me a negative. So I'm going to go up 2 and to the left, up 2 and to the left, up 2 and to the left. So then you just have to decide our boundary line is -2, so x is -2, and then that's our starting point. So do I want points on the right or do I want points on the left? And you notice it's pointing to the right, so I want ones that are greater than. So I want these points this way. Okay, so that dot's not needed, and it's not an or equal to, because the or equal to is the ones that gets the filled in dot. So in this case, this one's going to get an open dot. Okay. All right, so go ahead and try the last one. The last one is a u-try. So y equals half x plus 3 if x is less than or equal to 1, and or f of x equals -2/3 x plus 5 if x is greater than 1. All right, so let's graph these. Remember, we have two functions, which is y equals half x plus 3 So I'm going to graph 1, 2, 3, and then I'm going to do my slope. Up 1 over 2, up 1 over 2, up 1 over 2. And then I'm going to do the other way. But remember, got to have the same slope. So in this case, I'm going to go down and to the left. Down 1 and to the left. Okay. And x is less than or equal to 1. So remember, less than left. And my point is 1. Now if you notice, I don't have a point at 1. So we're just going to go ahead, basically we can connect these dots to kind of get where your point would be at. And then, so this is where my starter is, and since it's an or equal to, it is a closed dot. Okay? So I don't need anything beyond that. Okay? So the next equation is y equals 2/3 x plus 5. Actually, it's -2/3. So my y-intercept is 5. 1, 2, 3, 4, 5. I'm going to go down 2, 1, 2, 3. Down 2, 1, 2, 3. I could also go up 2 and to the left. 1, 2, 3. Okay. So when I graph those, remember I want points that are less than 1. So let's go ahead and connect these. So I want points on the left. And remember, that dot at 1, since it doesn't have an or equal to on it, is an open dot. So that's what your graph should look like. Okay. So as a quick wrap up, remember the only things that you really have to be concerned about are that you have two functions that you have to graph. Okay. Just like we graphed in quick graphs in lesson 2.3, pull out your slope, pull out your y-intercept. So your slope, your y-intercept, your slope, and your y-intercept. But now, instead of wanting the entire graph, when you graph this function, we only want things that are less than or equal to 1. And when we graph this one, we just want things that are greater than. And those may get changed up, so you're going to have to watch the way it points your sign.